Here is the start of our notes on 6.2, coordinate geometry and the Pythagorean theorem. So for these review problems, I would like you to try them without me and see how you do. If you look in the middle of your page, the distance formula is there for you. Or if you need a refresher, it's the square root of parentheses, right? These are what I call the bones. This is what you're going to fill in. So pause the video and try that for both of these. If you get stuck when you want to check your answer, go ahead and press play. So distance formula. We have these are our x's, right? So I'm going to say -4 minus 2 quantity squared. Our y's are 8 and 3, so 8 minus 3, right? Draw your radical symbol. -4 minus 2 is -6 squared plus 5 squared. -6 times -6 is positive 36. 5 times 5 is positive 25. So we get the square root of 61. Round to the nearest tenth. So plug that in your calculator, convert it to a decimal. You should get 7.8. Okay, so same thing with the next one. -3 and +2 are my x's. So I'm going to say 2 minus -3. My y's are 4 and this -3. I'll have -3 minus 4. 2 minus -3 is the same as 2 plus 3. So here I have 5 plus -7 square root of 25 plus 49 equals the square root of 74. And then your final answer, I'm going to write it all the way up here, 8.6. All right, so that is the distance formula. Now I would like to show you a different way. So combining the Pythagorean theorem and the distance formula, because this is what we will be doing in our notes. Okay, so I could set up a distance formula, plug it in, and do what I just did. Or I could draw a right triangle. So you come all the way down to where B is, right? So I draw a vertical line down from A, horizontal line from B, and all of a sudden now I have this right triangle where AB is my hypotenuse. So I'm going to count 1, 2, 3, 4, 5, 6, 7. This is 7. 1, 2, 3, 4, 5. Here I have 5. So if I want to find x, we know that x squared equals 7 squared plus 5 squared. So x squared equals 49 plus 25. Oops. And if I take the square root of both sides, x equals the square root of 74, which is still 8.7. So if you look up here, you'll notice I did the exact same thing, right? I got to the same spot, 25 plus 49 under the radical. So that's a little shortcut for when we have a coordinate plane like this. So this is how we're going to do our notes. Making a right triangle and using the Pythagorean theorem. But before we do that, I want to make sure we all know how to use radicals and how to manipulate them. So here is the basic Pythagorean theorem, except our numbers get a little strange. So side squared, right? Here's our hypotenuse. It's across from my 90. So I have x squared plus the square root of 13 squared equals 4 squared. Side squared plus side squared equals hypotenuse squared. Leg squared plus leg squared is hypotenuse squared. So x squared stays. The square root of 13 is 13. Okay? The square root of 13 squared. The square root and the square, they cancel each other out. And it just becomes 13 equals 16. Subtract 13 from both sides. X squared equals 3. Sorry, let me write that again. X squared equals 3. We take the square root of both sides, and x equals 1.7. That's our final answer. Okay, same thing over here. Notice this one here is my hypotenuse. These are my legs. They make the right angle. So 10 squared plus x squared equals the square root of 197 squared. So here I recommend pausing the video, getting the answer, and checking your work. 10 squared is 100 plus x squared equals 197. The square root of 197 squared is 197, right? These cancel each other out. Subtract 100 from both sides. X squared equals 97. Take the square root of both sides. X equals 9.8. And that's your final answer. So now that we remembered those things, we've noticed those things, we're going to do these notes. Okay, so this is how the whole page looks. I'm going to break it up into 2 slides because that's easier for me to write. So here we go, part 1. Oops. Sorry. All right, here we go. Okay, step 1. I want you to make the triangle inside of a rectangle. I'm going to draw a rectangle. So I'm going to connect all my vertices. So I'm going to go straight down from B, over, up, and over. So you see every vertex of my triangle is sitting on my rectangle. It's inscribed. And now I have these 3 right triangles. Okay, so let's start with AB. Right, so AB is this triangle here. So what we're going to do, we're going to count our sides. Here, this side of the triangle is 1. This is 1 unit. And then I count up 1, 2, 3, 4, 5, 6. This is 7 units. So I'm going to use the Pythagorean theorem to find AB. So you say AB squared equals 1 squared plus 7 squared. So AB squared equals 1 plus 49. So AB equals the square root of 50. Right? If I take the square root of both sides, you get rid of that, and then I combine 1 plus 49 is 50. So notice here it says leave your answers as a radical. So I want you to leave your answer here as the square root of 50. Okay, so now we're going to do the next one. BC. So BC, we go up here, over here, and down. So here, this side is 3. I count this side is 4. So BC squared equals 3 squared plus 4 squared. So BC is the square root of 25. And we're going to leave it like that. Even though you can make it 5, for the purpose of this, I want you to leave it like that. Okay, and then the last one, AC. So here I count, this is 3 and this is 4. AC squared equals 9 plus 16. AC squared equals 25. And AC equals the square root of 25. And again, I want you to leave it just like this. So these are my 3 sides. Okay, so now we're going to check, is it a right triangle? So we're going to take the 2 smaller sides, the square root of 25 squared plus the square root of 25 squared, and we're going to see, does that equal the square root of 50 squared? Well, and this is why I told you to leave them in the radicals, because now these will cancel and you get 25. These will cancel and you get 25. These cancel and you get 50. So 25 plus 25 equals 50 equals. So our answer is yes, it's a right triangle. Okay, do I have a right triangle? Yes, because side squared plus side squared equals hypotenuse squared. And we'll talk about rounding error next time, but that is why I want you to leave them in radicals, because of rounding error. And so this method, method 1, is math heavy. You can choose between method 1 and method 2. We'll look at method 2 next. But this has more calculations. But I think the next one, slope, has a little bit more room for error. Okay, so I'm going to go ahead and redraw my rectangle here. So this is 3, 4, 7, 1, 3, 4. Okay, so now we're finding slopes. So the slope of AB. So let's find AB. So going from A to B, rise over run, right? Changing the Y's over changing the X's. So this is a positive. I go up 7 over 1. And if I simplify that, it's just 7. For BC, I check, it's also a positive slope. It's going up. I go up 3 over 4 to get there. So positive 3 over 4, can't reduce that. And then, rise over run. And then the last one, AC, notice this goes down, this is negative, down 4 over 3. So here you really have to pay attention to, is it a positive slope? Is it a negative slope? Vertical change over horizontal change, right? Rise over run. But we didn't have to do nearly as much math, we just counted. However, now we need to write a few sentences. And yes, I expect you to write these sentences. Okay, so are any of these slopes opposite reciprocals? I want you to say yes, right? BC and AC. Positive 3 over 4 and negative 4 over 3 are opposite reciprocals. So do you have a right triangle and why? And I want you to write the whole sentence. Yes, since BC and line segment AC have slopes that are opposite reciprocals, BC is perpendicular to AC, making triangle ABC a right triangle.